Alright guys, this section of notes is going to start out as a review, and then we're going to go into the different instruments and tools that we use to measure some of the weather properties, and we're also going to talk about weather forecasting and what those symbols look like on a weather map. So let's review first. You guys should remember at this point that high pressure means it's going to bring good weather. If you're on a high, you're feeling good, okay? If you're high on life, everything's going great for you, then high pressure means good weather, okay? And in high pressure areas, what you're going to have is that cold falling air rotating counterclockwise, okay? So you can see in the picture down here, you have your air rotating counterclockwise. Now, in the other type of pressure system, which is a low pressure system, low pressure systems bring bad weather. So a way to remember it is if you're feeling low, you're having a bad day, low pressure systems bring bad weather, okay? And with a low pressure system, that's where you have your warm air rising, and then it cools and gets into the atmosphere, forming a bunch of clouds. The air rotates clockwise in this situation, and it brings bad weather. The fronts that we talk about, make sure you remember that a front is a boundary where two unlike air masses meet. So with a cold front, those are our fast-moving fronts, so they're the quicker moving fronts. And cold overtakes warm. It pushes that warm air up, and it goes over top of the cold air mass. And remember, cold air is much more dense, so it's always going to go at the bottom, and warm air is less dense, so it gets pushed up. And you can see that in this picture here. The warm goes up, and the cold air is going to advance in. Okay. Whenever we have cold fronts, you're going to see precipitation, and most likely thunderstorms occur with cold fronts just because they are so abrupt and fast-moving. The next type of front is a warm front, and in this situation, you have your warm air coming in, and that's going to be overtaking a cold air mass. And what it's going to do is it's going to push it and rise above it, and when that happens, we're going to have a little bit of precipitation. The third type of front is a stationary front, and that's just as it sounds. When things are stationary, they're not moving. So a stationary front is whenever you have your warm and your cold air mass meeting, but neither one is going to overtake the other. So instead, they experience a standoff. Whenever this happens, it's going to bring rain, and depending on how long the standoff is, it can possibly bring extended periods of rain. The last front is an occluded front. And the occluded front is one of our most complex fronts because it contains three air masses. So you're going to have two cold air masses and one warm air mass. The warm air mass, as you can see, gets caught right here in the middle. And whenever the two cold air masses collide, they push that warm air mass up. And whenever that warm air rises upward, we are going to be able to expect precipitation with this type of front as well. Now we keep talking about these air masses with fronts, and remember that an air mass is going to be a big body of air that's going to have similar temperature, humidity, and air pressure within it, okay? The key words to remember as far as moisture goes is maritime and continental. Maritime means it's going to form out here in the ocean, okay? Whenever it forms over the ocean, it's going to pick up that water from the water source, and it's going to bring moist air. Okay, now with continental air masses, those form on the continent. Okay, so these are ones that are forming over land, and because they're forming over land, they don't have a body of water to go over to pick up moisture, so these are our dry air masses. Next two types of air mass talk about the temperature of the air mass, and that goes over tropical and polar air masses. We know in our tropical areas, these are areas that form over warm spots, especially near the equator. So if we have a tropical air mass, it's going to bring warmer weather. If we have a polar air mass, that's going to form, as you see out here, up in the northern areas. Polar air masses are going to bring colder weather. And then you can see down at the bottom, our tropical air masses bringing warmer weather. For clouds, the main type you need to know are cumulus, which is your typical fair weather cloud. They look like the big white puffy cotton balls. The stratus clouds are also low-level clouds, and they kind of cover the sky like a blanket. They typically bring rain. And then if you throw the word nimbus with any cloud, nimbus means rain producing. So if you see nimbus in any part of a cloud name, it's going to be bringing rain. For example, we have nimbostratus. Stratus are low-level blanket clouds. Nimbo means precipitation. Put it all together. Low clouds that blanket the sky and bring precipitation. Same for cumulonimbus, which is a big cloud name you need to remember. These are known as thunderheads because these are our clouds that bring our bad weather, like thunderstorms. And they form whenever our warm air is going to be pushed up quickly by updrafts. And they bring precipitation, lightning, thunderstorms, that kind of stuff. And the last word that you need to remember with clouds is the prefix alto. So if alto is thrown with any of the clouds, like alto cumulus, an alto cumulus cloud is going to be up higher than a regular cumulus cloud. Same for alto stratus. You see I just highlighted alto stratus, and then below it is the normal stratus cloud. So you throw that word alto on there, and it's going to make it a little bit higher. So let's start talking about meteorology. A person who studies the causes of weather and tries to predict it is called a meteorologist. They're going to use multiple forms of technology. They're going to look at maps. They're going to look at charts. They're going to have computer programs to analyze all this data that's being sent back to them from satellites and weather balloons. And based on trends and patterns, they predict the next, couple of days worth of weather. So let's talk about different weather tools. The first is a barometer, and a barometer measures air pressure. Remember how when I taught you guys about air pressure, we talked about another word for air pressure or atmospheric pressure was barometric pressure? Okay, the barometer measures barometric pressure or air pressure, all right? It can be a barometer that contains mercury, which will rise and fall based on the air pressure. Or it can be an aneroid barometer that uses millibars to measure it. So if the pressure drops, which means low pressure is there, that's going to be bad weather. Of course, you know that. Drops, bad weather. There you go. And if the pressure rises, we're going to have some good weather. All right, high pressure brings good weather. And here you can see a picture of a barometer. The next tool you all know, a thermometer. It's going to measure our temperature changes. So if our molecules are moving fast and they're far apart, they're going to be warm weather molecules, okay? When those molecules are moving fast and they're bouncing off of each other and they're far apart, that's going to represent warm temperatures. If our molecules are moving slow and they're huddled up together, that's going to bring cold weather, okay? So that represents the temperature of it being cold. Next we have a psychrometer, and that's going to measure humidity. A psychrometer has a handle that you swing, and there's going to be two thermometers mounted on that handle. One thermometer is going to be a regular one, and the other is called a wet bulb thermometer. So there's a dry bulb and a wet bulb, and you spin the handle, and the wick is dipped in water, as you see right here on the end. And as you swing it, it is going to show you the amount of humidity in the air. The next tool is an anemometer. And anemometers measure the wind speed. So an anemometer is going to show you the speed, like whether it's 15 miles per hour or just 3 miles per hour, and also going to show you the direction, okay? It has these wind direction sensors to measure what direction the wind's blowing and also how fast it's blowing. We have several different types of radars and satellites, so you just need to know that a radar is an electronic instrument that's going to determine the direction and distance of objects. It's going to reflect radio energy back to the radar site, and that's what the meteorologists are going to use to see the different forms of precipitation and to kind of see how strong those things are going to be, whether it's just going to be light in some areas or stronger in others, whether it's going to be snow in some areas or come down as rain in others. Specifically, the Doppler radar is our one that's going to detect the intensity of how strong the precipitation is. It'll give us wind direction, it'll give us wind speed, it'll give us estimates of rainfall amounts. The Doppler radar is going to be the main thing that gives our forecasters the capability to detect these severe weather situations and let us know ahead of time. So they're able to send out watches and warnings to let us know. And these satellites and radars also can give forecasters the tools to do this as well. Satellites, which I just talked about, is a tool that's used to monitor the weather and climate. So satellites see more than just clouds and the systems. It sees city lights, fires, effects of pollution, sand and dust storms, snow cover, anything you can imagine, satellites are going to pick up on. And it sees all these different types of environmental information that it can collect and send back to the meteorologist. Okay, these are really cool. So looking at symbols here, we have a cold front symbol. And that cold front symbol that you guys see is represented by triangles, okay? So I tell my kids to think of icicles, cold icicles hanging off of the edge of your house. And that'll remind you that triangles stand for cold weather. The warm fronts come through, and they are typically red for warmth. And they're little half circles. And I tell my kids to remember it because it looks like a little sunshine coming on the horizon. All right. Occluded fronts, I'm going to have to redraw for you guys because for some reason it didn't turn out right. Occluded fronts, remember, are your most complex fronts, and that is when you have a warm front caught in between two cold fronts, or two cold air masses, I'm sorry. So it'll be triangle, half circle, triangle. And then the stationary front is whenever you have a warm and cold air mass, but they don't move each other. So you'll have your warm on one side and your cold on the other side. So half circles on one side and triangles on the other side, showing that they're going against each other. It's very important to know that whichever direction that your symbols are pointing, that's the direction that the front's moving. So this cold front here has the symbols pointing down, so it's moving south. The warm front has its symbols on top, it's moving north. Occluded front's down, so south. And then your stationary front actually is not going to have a direction because it is stationary. It's not moving, okay? So when we talk about pressure systems and high and low pressure systems, good and bad, these are easy because they're just represented by the letters. So you see low pressure is an L and high pressure is an H. For wind speed, you have these circles with shafts coming off of them. The circle is going to show cloud cover, and the shaft, the long shaft that comes off of it, is going to point in a specific direction that the wind's blowing. So I'm going to highlight what I'm talking about. These long shafts right here show the direction that the wind's blowing, and then the little itty bitty tick marks coming off of it represent how fast the wind is blowing. So we mentioned that the circles represent cloud cover, and how much it's shaded is going to tell you the percentage of cloud cover that there is. So in this first one here, it's not shaded at all, which means it's clear. You're going to see clear skies. This one is a quarter of the way shaded, so 25% cloud cover, scattered clouds. Halfway is partly cloudy, 3/4 of the way is mostly cloudy, and if it's completely covered in, that means it's going to be overcast. The next two terms are isobars and isotherms. The prefix iso means same. Okay? So same bars, same therms. When you think of a therm, you should think of a thermometer, which measures temperature. And when you think of bars, you should think of barometric pressure. So isobars are going to be showing areas of the same pressure. All right? So these are both represented by lines on a weather map. And isobars are going to go through any area that has the same barometric pressure. So if there's an area with 1,014 millibars of pressure, then any area in the United States that has that specific pressure, there's going to be a line going through, and that's an isobar. Now, the opposite of an isobar is an isotherm, and those are going to be lines on a weather map that are going to connect areas of the same temperature. So any place in the United States that is 80 degrees, then there's going to be a line going through all those areas that are 80 degrees, and it'll be marked. So, like, for example, if you see right here where I'm trying to outline, all of those areas would be 80 degrees, okay? That is an isotherm. And when I mentioned over here by the isobars, you just find a line and you follow it. Okay. Now this map is showing you a lot about wind. It also has a bunch of different things on it. So for wind, remember that the actual long shaft coming off is going to show you the direction that the wind's blowing, and the tick marks is going to show you speed. So, for example, the wind's up here. You see that the shaft is pointing to the east and up north, so I would say those winds are moving northeast. And it doesn't have any tick marks coming off of it, so it would fall under this category, 1 to 2 miles per hour. Okay, now there's also on this map some isobars that show us areas of the same barometric pressure. So all the areas that this one goes through have a barometric pressure of 1012. And then we also see here a low pressure system, and there's a high pressure system. And then here we see a warm front, and we look at where those shapes are, and they're pointing this way, which is northeast. And here is a cold front, and those are pointing down and to the east as well, so those are moving southeast. All right, this weather map, we're going to focus on pressure systems. You see a high pressure system and a low pressure system. Notice by the low pressure system here, we have all this severe weather. All right, that's because with low pressure systems comes bad weather. Up here by our high pressure system, there's not a lot of precipitation going on at all. And that's because high pressure systems bring good weather. Okay. You'll also notice that whenever we have this advancing cold front coming in, that's where we see a lot of severe weather, and that's because when cold fronts rapidly approach, we're going to see a lot of severe weather. All right, this slide is fronts. We're going to look at the different fronts here. Here we see a cold front, and it's moving southeast. This is a warm front, and it's moving northwest. Looks like it's going that way. And then here we have another cold front moving southeast. Okay. You look at the direction in which this shapes are pointing, and that tells you the direction that that front is moving. Notice here, just for reminders, there's our high pressure system, not a lot of bad weather surrounding it. And then some low pressure systems where we do have bad weather surrounding it. Remember that low pressure systems are going to be bringing bad weather. And we also have a key up here that shows us the types of precipitation you can expect. And there's also a key that shows us that yellow equals fog. And that is all I have for you guys. If you have any questions, then you need to see me in class.